Welcome to Python File Input and Output Operations. Files are everywhere in programming: configuration files, data storage, logs, and user documents. Today we'll master reading, writing, and managing files in Python. You'll learn the essential skills every Python programmer needs for working with the file system safely and efficiently. Files are collections of data stored on your computer's storage system. They can contain text, images, data, or any type of information. In Python, we work primarily with text files and binary files. Text files contain human-readable text, while binary files contain data in formats that programs understand directly. Text files include common formats like text, CSV, JSON, Python source files, and HTML. These contain readable text that you can open in any text editor. Binary files include images, PDFs, executables, audio files, and compressed archives. Today we'll focus primarily on text files, as they're most common in everyday Python programming. Files are located using paths, addresses that tell your computer exactly where to find a file. A path includes the directory structure, the file name, and usually an extension that indicates the file type. Understanding file paths is crucial for file operations. When opening files in Python, you must specify a mode that tells Python what you plan to do with the file. Different modes allow reading, writing, appending, or combinations of these operations. Let's explore the most important file modes. Here are the essential file modes. R opens for reading only and requires the file to exist. W opens for writing and creates the file, but overwrites existing content. A opens for appending, adding new content to the end. The plus modes like R+, allow both reading and writing. X creates a new file but fails if it already exists, preventing accidental overwrites. The open function is your gateway to file operations. It takes a file name in mode, returning a file object that you can use to read or write data. Let's start with the basic syntax and see it in action. The basic syntax is straightforward. Open takes a file name in mode, returning a file object. You work with this object to read or write data. Then close it when finished. Closing files is crucial. It frees system resources and ensures data is properly saved. This warning cannot be overstated. Always close your files. Forgetting to close files can cause memory leaks, prevent other programs from accessing files, and risk data loss. Python provides better ways to handle this automatically, which we'll see shortly. Reading files is one of the most common operations. Python provides several methods for reading file content. Read everything at once, read line by line, or read into a list of lines. Each method has its best use cases. Method 1. Read. Reads the entire file into a single string. This is perfect for small files where you need all the content at once. However, it can use lots of memory with large files since everything is loaded into memory simultaneously. Method 2. Readline. Reads just one line at a time, including the new line character. This is memory efficient for large files since you only load one line at a time. It's perfect when you need to process files line by line without loading everything into memory. First. Method 3. Readlines. Reads all lines into a list, where each line is a separate string element. This combines the convenience of having all data available with the ability to process individual lines. Each line includes its new line character, so you often need to strip them when processing. Writing files lets you save data, create logs, export results, and more. Python provides methods for writing strings and lists of strings to files. Remember that writing in W mode overwrites existing files completely. The write method saves a string to the file. Important: write doesn't add new lines automatically. So consecutive writes will create one continuous line unless you explicitly add new line characters. This gives you complete control over formatting. Adding new line characters creates separate lines. The \n character represents a line break. This is how you create properly formatted text files with multiple lines. Each write call adds to the file sequentially. The writeLines method accepts a list of strings and writes them all at once. This is efficient for writing multiple lines. However, writeLines doesn't add new lines automatically either. So make sure your strings include them. You can also use a loop to write items with custom formatting. Appending is perfect when you want to add new content to an existing file without losing what's already there. This is essential for logs, data collection, and incremental updates. The mode positions the file pointer at the end. Here's append mode in action. We have an existing log file with entries from January 1st when we open in append mode and write new entries. They're added to the end without disturbing existing content. This is perfect for logs, data collection, and any scenario where you need to preserve existing information. Understanding the difference is crucial. Write mode completely overwrites files, destroying existing content. It's perfect for creating new files or completely rewriting existing ones. Append mode preserves existing content and adds new data to the end. It's ideal for logs, data collection, and any situation where you want to keep existing information. The with statement is the preferred way to handle files in Python. It automatically closes files when you're done, even if errors occur. This prevents resource leaks and ensures your files are always properly handled. Let's see why it's so important. Here's the problem with manual file handling. If an error occurs after opening the file but before closing it, the close statement never executes. The file remains open, consuming system resources and potentially preventing other programs from accessing it. This can lead to resource leaks and system problems. The with statement solves this problem elegantly. It automatically closes the file when you exit the with block, whether normally or due to an error. The as file part creates a variable you can use to work with the file. This is Python's recommended approach for all file operations. The benefits are clear. Automatic file closing prevents memory leaks. It works even when errors occur. The code is cleaner and more readable. You don't need to remember to call close. And it follows Python best practices. Always use with statements for file operations. Let's see real-world examples of reading files. These patterns appear constantly in actual programming projects. Reading configuration files, processing data, analyzing logs, and more. Example 1. Reading a configuration file. This pattern is very common. You have key-value pairs in a file that you need to load into a dictionary. We read line by line, strip whitespace, skip empty lines, and split on the equals sign. This creates a configuration dictionary your program can use. Example 2. Processing CSV-like data. We read the header line first to get column names. Then process each data line by splitting on commas and creating dictionaries. Using zip to pair headers with values is a clean way to create structured data. Finally, we can easily filter and analyze the data. Example 3. Analyzing log files. This is extremely common in system administration and debugging. We count different types of log messages and collect errors for detailed review. This pattern helps you quickly understand what's happening in your applications and identify problems that need attention. Now let's explore writing files with practical examples. These show common patterns for saving data, creating reports, generating files, and exporting results from your programs. Example 1. Creating a formatted report. This shows how to generate professional-looking text reports with headers, formatted columns, and totals. The F-string formatting creates aligned columns, and we calculate totals as we write. This pattern is perfect for generating summary reports and data exports. Example 2. Saving user preferences. Applications often need to save user settings between sessions. This example shows how to convert the dictionary to a simple key-value format. Handling different data types appropriately. Lists are converted to comma-separated values, and we add comments for human readability. Example 3. A simple logging system. Logging is essential for debugging and monitoring applications. This function adds timestamped messages to a log file using append mode to preserve previous entries. It also prints to console for immediate feedback. This pattern is the foundation of most logging systems. File operations can fail for many reasons. Files don't exist, permission issues, disk full, network problems. Proper error handling makes your programs robust and user-friendly. Let's learn how to handle common file-related errors gracefully. Here are the most common file errors you'll encounter. File not found error occurs when trying to read a file that doesn't exist. Permission error happens when you lack rights to read or write a file. Is a directory error occurs when you try to open a directory as a file. OS error covers disk space, network, and hardware issues. Unicode decode error happens with encoding mismatches. Here's how to handle file errors properly. Use try except blocks to catch specific exceptions and provide meaningful error messages. The first example handles the common file not found error. The second example shows handling multiple error types with specific messages for each. The general exception catch-all handles unexpected errors. This robust function demonstrates professional error handling. It tries to read a file but gracefully handles all common errors by returning default content. Instead of crashing, notice the encoding parameter, explicitly specifying UTF-8 prevents many encoding issues. This pattern makes your programs much more reliable and user-friendly. File paths can be tricky because they work differently on Windows, Mac, and Linux. Python's pathlib module provides a modern, cross-platform way to work with file paths. Let's learn how to handle paths properly for reliable file operations. Here's the path problem. Windows uses backslashes, while Mac and Linux use forward slashes. Hard-coded paths make your code non-portable. A program that works on Windows might fail completely on Mac or Linux because of path differences. Pathlib provides an elegant solution. Use path objects and the forward slash operator to build paths that work on all operating systems. Check if files exist before opening them to avoid errors. Create directories safely with mkdir and exist_ok. Path objects provide useful methods for getting file information and manipulating paths. Let's explore file modes in more detail with practical examples. Understanding exactly how each mode behaves will help you choose the right one for each situation. And avoid common mistakes like accidentally overwriting important data. This example shows exactly how each mode behaves. Read mode only allows reading. Write mode completely overwrites the file, use with caution. Append mode safely adds to the end. The R+ mode allows both reading and writing without truncating. But writing happens at the current position, which can overwrite existing content if you're not careful. Let's build a complete grade management system that demonstrates all the file I/O concepts we've learned. This system will read student data, calculate grades, generate reports, and handle errors gracefully, just like a real application. Here's the beginning of our grade management system. We use pathlib for cross-platform file paths, create directories safely, and implement logging for all actions. The system is designed to be robust with proper error handling throughout. These methods handle loading and saving student data using JSON format. We check if the file exists before loading, provide appropriate defaults, and log all operations. The save method returns a boolean to indicate success or failure, allowing calling code to respond appropriately. Here's how to use our grade management system. We create an instance, add grades for different students and subjects, generate a report, and verify the data. This demonstrates a complete file-based application with proper structure and error handling. The system automatically creates directories and files as needed. Let's discuss performance considerations and best practices for file operations. Understanding these principles will help you write efficient, maintainable code that handles files properly in production environments. Here are the essential best practices. Always use with statements to ensure files are closed properly. Specify encoding explicitly to avoid issues with international characters. Handle errors gracefully to provide good user experience. Use pathlib for portable code. Process large files line by line to avoid memory issues. Validate files exist before operating on them. Choose file modes carefully to prevent accidental data loss. These examples show performance considerations. Reading entire large files uses excessive memory. Process line by line instead. Many small writes are inefficient. Batch them when possible. For large file operations, use appropriate buffer sizes to balance memory usage and performance. These patterns make your code much more efficient with large datasets. Let's examine common mistakes when working with files and learn how to avoid them. Understanding these pitfalls will save you debugging time and prevent data loss in your applications. Here are critical pitfalls to avoid. First, forgetting to close files leads to resource leaks. Always use with statements. Second, using write mode when you mean append mode destroys existing data. Third, not specifying encoding causes crashes with international characters. Fourth, not checking if files exist leads to crashes. Each pitfall has a simple solution that makes your code much more robust. Let's explore some advanced file operations that are useful in real-world applications. These techniques handle file positioning, temporary files, and atomic operations to make your file handling more sophisticated and reliable. These advanced techniques solve real-world problems file seeking lets you read and write at specific positions. Temporary files provide safe workspace for intermediate operations. Atomic file operations prevent corruption by writing to a temp file first, then replacing the original only if successful. File locking prevents conflicts when multiple programs access the same file. These patterns are common in production applications. Different file formats require different approaches. Let's see how to work with common formats like JSON for structured data, CSV for spreadsheet data, and configuration files. Each format has specific considerations and best practices. JSON is perfect for structured data with nested objects and arrays. The JSON module handles conversion between Python objects and JSON text. Here we save a dictionary into a JSON file and then load it back. CSV files are great for spreadsheet-like data. The CSV module handles writing rows properly, including escaping and quoting. When reading, you can skip the header and process rows one by one. Simple configuration files often use key-value pairs. They are easy to write and pass with just string operations. These are common for application settings and environment variables. Each file format serves a unique purpose. JSON works best for structured data, CSV for spreadsheets, and config files for application settings. Congratulations! You've mastered the fundamentals of file input and output in Python. From basic reading and writing to advanced error handling in cross-platform paths. You now have the skills to work confidently with files in any Python project. Let's review the key concepts. File modes determine how you can interact with files. Remember that write mode overrides everything. The with statement is essential for proper resource management. Error handling makes your programs robust and user-friendly. Pathlib provides cross-platform file operations. Always specify encoding for text files to avoid character issues. Process large files efficiently line by line. Choose the right format for your data needs. Here's your quick reference cheat sheet for the most common file operations. This covers safe reading with error handling, writing and appending files, processing large files efficiently, and using cross-platform paths. Keep this pattern handy for your projects. You are now equipped with professional file handling skills. Practice with different file types and formats to build your confidence. Always implement proper error handling to make your applications robust. Try building your own file-based applications like to-do lists, log analyzers, or data processors. Remember the fundamental cycle: read data, process it, and write results. File I/O is the foundation of data persistence in programming. Start applying these skills immediately. Build a log analyzer to process server logs. Create a configuration manager for application settings. Develop a data processor for CSV files. Or build a report generator. The best way to master file operations is through hands-on practice with real projects. File input and output operations are fundamental skills that every Python programmer must master. You've learned not just how to read and write files, but how to do it safely, efficiently, and professionally. These skills will serve you throughout your programming journey, from simple scripts to complex applications. Keep practicing, keep building, and remember, mastering file I/O means mastering data persistence. Thank you for joining this comprehensive exploration of Python file operations. You now have the knowledge and confidence to handle files professionally in any Python project. Remember to always use with statements, handle errors gracefully, and choose the right tools for each task. Happy coding!